Hi, this is a question about the kinematics taken from the practice exam 2019. You can see a card that is moving in a negative x direction with what velocity as given in the question is negative 3 meter per second. So I'm taking leftward direction negative. So acceleration for this card have a minimum and the maximum values 3 and the 6. It means that it can have acceleration of any value in between them, but the acceleration is constant. Okay. So we have to find out the instantaneous displacement at this time at 1 second. Now we have to find out the range of the distance displacement basically. So this is the reference point from where we are measuring its position. Okay, and this is an initial position which is 10 meter, which means the initial position is positive. So let's say so so let's talk about the first scenario when the minimum force is applied. That minimum force will cause the minimum acceleration, which is 3 meter per second square. And remember, this acceleration is positive. In fact, the acceleration is not exactly 3. It will be more than 3, but we are taking just a case that if the minimum acceleration is 3, so it is due to this force. So this force will cause the minimum acceleration 3 meter per second square. So due to this minimum force, this card will be able to travel more distance. So I mean to say, let's say the card's new position at 1 second is this, okay, because the card has traveled more distance leftward. So this is the minimum position, right, that we need to calculate. So obviously we will apply the kinematics equations. And which equation? We should apply this equation because we are given the instantaneous time. Okay, so this is a change in position, which is the final position minus initial position, is equals to the initial velocity is negative 3 and the time is 1 plus 1 over 2 into acceleration is positive 3 and this is 1 square. So students, we have the minimum displacement covered is negative 1.5 plus 10 if we add 10 on both sides, so that will be 8.5 meter. It means that this displacement is 8.5 meters when the minimum force was applied and the displacement when the acceleration was 3. Okay, but just imagine if you are applying the maximum force. Now this time you are applying the maximum force due to which the acceleration is maximum, this one, right? Now the card will not be able to cover that much forward distance. So in fact the new position of the card is, let's say, at this point. So don't you think the position should be more than 8.5? So that's why obviously the answer should be B. But if you stick with the video, I can just quickly explain you why it should be the 10 meter. So we are going to apply the same equation once again at the instantaneous time 1 second. We want to find out the new displacement. So this is the final displacement. Final position minus the initial position is positive 10, but since it's negative, it's a change in position is equals to the negative 3 into 1 plus 1 over 2. Now this time I'm going to put here 6, okay, because acceleration is 6. So here you see that the maximum displacement would be 10 meters if acceleration is 6. But since the acceleration is neither 6 nor 3, it is in between 3 and 6. So that's why your displacement cannot be 8.5 or 10. It will be also in between. It would be more than 8.5 meter and it would be less than 10 meters. So that's why the option B should be the right answer.